Hi, this is Terrorist 101 with Kunj, Christian, and JC.
AKA Mama Thickness.
And we will be experimenting with many things today.
Alright, so what we're gonna do is we're gonna make some potassium chlorate, okay? And whenever we add things like sugar molecules and starches and proteins to it, it does all sorts of weird stuff.
Like what?
Like, so wait, this is where we got the idea though. We were on YouTube one day.
No.
And we were just like, we gotta find something cool to do for the chemistry part.
No.
Are you ready? You ready?
Tell him.
I typed in gummy bear, you know what comes up? It says gummy bear potassium chlorate.
Oh, hell nah.
Alright, so let me tell you how it is, alright? You make some potassium chlorate, you heat it up, you put the gummy bear inside, and then boom! Explosions!
The experimental variables of this project is the raw pasta, which is a starch, the sucrose, which is the gummy bears, and a protein, which is the beans.
The controls for this experiment are going to be the mass of starches and the protein that you put in to mix, and the amount of potassium chlorate we're going to mix with it, and obviously the room, the time, and the area we do it in.
So, we're going to start with a solution of bleach which has sodium hypochlorite, and then whenever you boil that, it yields sodium chloride and sodium chlorate. One is a crystal, or sodium chlorate is a crystal and sodium chloride is a liquid. So they're separated, and then we can work with sodium chloride. Okay, so what we have is KCl is a solution that we prepare. It's a saturated solution of potassium chloride. We just take potassium chloride, which is a salt substitute, and we add it to water, and we get saturated solution. And then we add it to the sodium chloride, which we got from the previous reaction. And whenever you do that, double replacement occurs, and you get NaCl, sodium chloride, liquid, and you get KClO, which is a crystal, and that's the potassium chlorate. That's KClO. And then we do a lot of cool stuff with KClO.
You're the worst. The three substances we use for the experiment are raw pasta, gummy bear, and bean. Raw pasta contains a starch, and when you mix it with 6O2 from the KCl3, which is potassium chlorate, that we get from the reaction above, it produces carbon dioxide and water. And the gummy bear starts off with the sugar and goes same thing with 6O2, and then goes CO2 and H2O. And the bean has a protein, and then it goes 6O2 and it has CO2 and H2O also.
Then that gives you all these weird, awesome reactions, which y'all will see in just a few minutes here. What we did was we didn't add salt to the bleach. So what we did was we evaporated water out of the bleach, which gave us sodium hypochlorite. We needed to add salt, so it created a double reaction and desynthesized into sodium chloride and sodium chlorate. So we got the wrong substance. Yeah. So we're gonna redo that part, but we did get the saturated solution right for potassium chloride.
We're starting.
So I got one. Just mixed everything together because it's not working. So let's just mix everything together and see what happens.
If it doesn't work, I'm gonna cry.
If it doesn't work, then yeah, Jason's gonna cry, and I'm going to break Hudson's face.
Oh no! This is.
We have to stir.
Do you?
What was this?
Nothing happened.
Alright, right now I'm bleaching.
So because our first experiment was a complete failure, we're switching experiments, and for this we're going to be putting a gummy bear, which is glucose, into 3 different oxidizing agents, which is potassium nitrate, potassium permanganate, and hydrogen peroxide, to see which one will have the greatest reaction.
We believe that potassium nitrate will have the biggest reaction because it is often used as a replacement for potassium chlorate, which we couldn't make.
Okay, now we'll do the experiment of glucose and potassium nitrate. Das potassium nitrate. Das. And it makes CO2 and H2O and KNO2. Oh, I did something!
Yeah, it's
Yay,
working.
It worked! Ew, that looks disgusting. Turn on the. Turn it on. Oh! Black magic.
Look.
Oh, dude, look at the reaction. Did you hear that?
Yeah. So we're about to react this. It's potassium permanganate plus glucose, and what it does is it creates a really, really exothermic reaction. And we are predicting that it's going to be the second strongest. So
I just watched a lot of YouTube videos.
Use the Waybos that we have, right? Are you using the Waybos we have?
Yeah.
The Waybos on the bottom is there.
oops, bro.
Ew, it's bubbling.
Starch.
It's bubbling. It's bubbling.
Uh-huh.
Look at the bottom.
The last experiment we're doing is hydrogen peroxide and glucose. Unlike the others, this is the least reactive. And here's the chemical equation, and here's the experiment.
Do we have what's left of the potassium nitrate?
There you go. Nothing happened.
Gummy bear melts.
After all of our experiments, this is what we came up with.
Well, here we added potassium permanganate with 2 gummy bears, and nothing happened at first, but when we added hot water, it caused there to be an aqueous solution, and it caused somewhat of an exothermic reaction, and this is what happened to it.
We heated up potassium nitrate to make it molten, and then we added gummy bear to it, and it made a pretty violent reaction. The gummy bear jumped and stuff. So it was the most exothermic oxidizing agent, so it was the strongest.
For this one, we boiled hydrogen peroxide, and we added the gummy bear. There was a little reaction. There was a few bubbles, not that much. And the gummy bear melted. So basically, this is the weakest oxidizing agent.
So, in conclusion, our hypothesis was, in fact, true. The potassium nitrate did react the most with the glucose, and it was the best oxidized agent. So, for my standards, I think we went pretty well the whole experiment, except the fact that we could make potassium chlorate, but that's okay. So, yeah.
Recording. So shout out to Jordan Bismarck for spilling vegetable oil everywhere and not cleaning it. We have to. Can't wait till you see this. You jerk.
Stop moving, Casey. Oops.